Alright, so we want a linear time approach to solving this problem. First of all, let's see what is the bottleneck here, right? Because as you can see, the second part of our algorithm is indeed big O of n, and indeed doesn't use extra memory. So this is big O of n with big O of 1. It's the best we can get. So the only problem here is actually the remove duplicates part. We need to transform our initial array into an array that has only distinct values and is also sorted increasingly, right? Because I need to be sorted increasingly if I want to check in this way, right? So let's see how I can remove the duplicates in the follow-up, in which I know that the elements are actually pretty small. Well, you might have come up with a solution for this, because if you think about it, I don't know if I mentioned this before, but there is a type of sorting that is actually based on the fact that the elements are pretty small, and that is called counting sort. It is no problem if you don't know about counting sort. It is so simple, you are going to see. So one thing is the counting sort, right? So the small values are a hint for counting sort. And also the small values are a hint for a data structure that we have just learned, which is of course the frequency array, right? And indeed, the frequency array is actually the foundation of counting sort. So you've probably guessed it, we are going to sort this array not by applying any sort algorithm that is based on swaps, always swapping two elements and stuff like that, but one that is based on counting how many times each value appears. And also, because we just want to keep the distinct values, so each distinct value once, we don't need to count for how many times each value appears. We just need to count if that value appears at all. Because it appears once or 3 times or 10 times, it doesn't matter. It appears, so I'm going to just push it once into my final array. So let's take again that example and see how this count sort actually works on that array. Alright, and here we are. So we have this example and we have our frequency array, right? This is going to be an array of booleans. We just need to store true or false whether we have encountered that value or not. So the array is initially consisting of 1001 elements, which are all of them 0 or false, right? And we are going to iterate through the array, and for each value that we encounter, we are going to mark it as true. So as you can see, I definitely haven't written all the 1001 zeros, but let's just, I just written all the values that are important for this example. So if I start with the first value, this is 180. So what I'm going to do is, of course, instead of 0 here, I'm going to have a 1. Then I have 30. So instead of a 0 here, I'm going to mark it as a 1, as true. Then I'm going to have 80. So this value will be marked as true. Then I have 280. So this value will be marked as true. Then I have 130. This value will be marked as true. 330. Oh, I missed 330. No problem. Let's say this was 330, right? And I don't know, somewhere here it is 1000, which is 0. So yeah, this is 1, also 230. This is 1. And yeah, as you can see here, I have 30. So I'm going to mark it as a 1. It's already marked. Doesn't matter. I can mark it again, or I can leave it like this. It's going to be true. 40 already marked. 340 already marked, and 80 already marked. So, as you can see, I've finished iterating through the elements of the array, and I've marked these elements with 1. Now, what I'm going to do is that I'm going to iterate through the frequency array, of course, from left to right, so in the order of the values. So I'm going to start from value 0, right? What I'm going to do is, now I can empty the nums array. I can do that, or I can store, of course, a pointer. Let's say I can start with a pointer, not actually here, with a pointer here. Let's do the pointer thing. It's actually very similar to to the remove duplicates approach which was in place. We can have a pointer, and what we're going to do is iterate through each value, right? From 0 to 1000 and check if I have a 1 or a 0 there. So 0, that means the value 0 doesn't exist. 0, the value 1 doesn't exist. 2, and so on and so forth. The first value, such that frequency array of that value is a 1, is 30, right? So my first value is going to be 30. Now, what do I do? Is this 180 will be replaced by 30, and of course now P is going to be here, right? Now, what I'm going to do, I'm just continuing, and I continue, and I find 80. Perfect, 80 has a 1. So the value on the index P, where is my pointer, right, is going now to become 80, and I just move the pointer. Cool. Now, iterating, I find 130. So what do? This one becomes 130, and the pointer moves here. 180 is the next one, right? This one becomes 180, and the pointer P moves here, and I continue, and you can see 230, right? Then 230, then all zeros, then I find 280. So where P was left here, 280, P goes here, 330 is the next one which has a 1, 330, also increase P is here, and I don't find any. So what happened is that I've iterated through each and every value from 0 to 1000, right? So obviously if the problem gave me like values less than or equal to, I don't know, 1 billion, 10 to power 9 or 10 to power 10 or something like that, I don't have enough memory to make a frequency array. Yeah, what you could do is, of course, use a hash map or a set or an unordered set. If you know about it, if you don't worry. These are anyways future chapters. But for now, in this follow-up, a frequency array would be enough for how small the values are. And in the end, what I'm going to do is, of course, the new n is going to be P, because the length is where the pointer P is left, right? So in this example, P is 0, 1, 2, 3, 4, 5, 6, 7. So n will become 7, as indeed we have 7 distinct elements. And also, because we have iterated through the frequency from left to right, we will have distinct values. We will have them in increasing order. So let's see how this code looks like, and then let's analyze the time complexity together. And look how simple the code for this is. So what I'm doing is that I'm creating an array which is filled with only false values, right? This is a Boolean array which has initially 1001 values of false for each and every value from 0 up to 1000. And then what I'm doing is that I'm iterating through the nums array, and for each value in this array, I just mark that value to be existing, right? So is existing a val equals true. Afterwards, what I'm going to do is set my pointer to 0, because I'm going to push the distinct values in place. And for each value from 0 to 1000, I'm going to have the value set in that position P. Afterwards, I increment the position P to be ready for the next elements. In the end, of course, I set n equals P because that's going to be our new length. So just creating the array is 1001 operations, right? Then I iterate through the array nums, and I just set the value to be true. So this is big O of n, right? Where n is the number of elements. Then again, this is constant, and here I also do 1001 iterations, and for this I do constant operations here, right? So we can have a 1001, big O of n, and also a 1001. Of course, between all these three, we are going to keep big O of n because it's the only one that depends on the actual size of the input, right? If let's say that we didn't have this constraint that told us that all the elements are less than or equal to 1000, and instead of 1000, let's say, I don't know, we note this by max val, right? When we have this like in a definition, in a notation with max val, yes, then we can say that we have big O of n plus max val, right? But in our case, max val is 1000, so yeah. because it's plus, it's not multiplied or something like that. It's not that important. So we can just say it is big O of n. So we have a big O of n in this first part in which we get the sorted array consisting of distinct values. And then if you can remember the second part, we also had a big O of n there. So this last approach is big O of n time complexity and memory complexity big O of max val, right? Where this max val again equals 1000. We can theoretically say it's constant, but again, if the interviewer doesn't like that, just say that if we note the maximum value by max val, we have big O of max val as the memory complexity. And that's it, guys. Enjoy coding, and as always, I'll see you on the next one.